Yeah. Good day, everyone. My name is Durowoju, and I have my partner.
I'm Komal Kartan.
So we are here to present our research project, which is consumer behavior on air transportation using machine learning. And for our introduction, we have the binary classification of consumer behavior. We have a research objective, and we have related works.
So this is the abstract of our project. So airlines are one of the most dominant transport systems, and every people around the world make decision whether to travel or not. Making a decision whether to purchase a ticket solely depends on the price, but in many cases it is more complex. Like we have to consider different factors before coming to a final decision. So, this paper aims to analyze the behavior of consumers specific to airlines on how different factors influence customers' decision. We will be using machine learning to classify the consumer's decision, that is either yes or no, and apply different techniques to our dataset and compare the performances. So, the main objective of our research is to understand the consumer behavior, in this case, the behavior of passenger with respect to the air travel. And this model will be usually help airlines to understand what they lack and how to and where to improve their services to make their customers happy and satisfied.
So for the data set, the data we used was collected from an airline passenger satisfaction survey, and there are more than 1 million entries in the data set, each of which is associated with a single person. The outcome is a decision made by that consumer on whether he or she will buy a ticket with that airline in the future. And there are 17 columns in the data set, 16 features and one target, and most of the data is numeric. And there are very few non-numeric columns which are transformed to numeric, and the data is normalized using standard scalar. And this chart displays the number of consumers that will buy a ticket in future. And the blue part of it represents the no, while the yellow represents the yes.
So next step is to transform the data. For this, we converted the non-numeric values to numeric values using functions, and then we filled in the missing values with a median. Also, we removed the unwanted features which we did not require. So this is how the data looks after the data transformation. All the data is in the numeric form. And the feature selection, we selected the most important features from our dataset and removed those which were not very useful. So below are some of the features like gender, age, class, flight distance, cleanliness, etc. And our target feature is buy ticket in future.
So the training data and test data. So we created our training and test using train test splits function, and it generates the training set and test set test sets. And you can also explicitly give the size of the training or test set in this function as a parameter. By default, it splits the data set into 75% and training set. And it splits the data set into 75% training set and 25% test set. And feature scaling. The feature scaling is a technique to use to standardize the independent feature present in data in a fixed range. And we have two types of feature scaling. We have minimum to maximum normalization, and the second one is standardization.
So we used the standardization technique to scale our features, and this is how the our data looks like after it is scaled. And these are the features and the correlation between them.
Okay, classification methodologies. We classify this data based on supervised learning. For our experiments, we use few different well-known classification approaches, and they are decision tree, random forest, k nearest neighbor, And these are primarily selected based on their widespread use, well understood behavior, and promising performance in various classification tasks. And SGD was used to fine tune our data to improve the accuracy of the model. And for the machine learning models, the figure one displays the decision tree and confusion matrix, and the figure two displays the random forest, and figure three displays the k nearest neighbor, and figure four displays the gradient descent.
So this is the result table of our models, and we have four accuracy measures like accuracy, F1 score, precision, and recall. From the data, you can see that random forest performed really well compared to the other models which we used. And we also applied deep learning to our project. So deep learning is a subfield of machine learning concerned with the algorithms inspired by the structure and function of the brain called the artificial neural networks. So this has been very useful, and they have produced results comparable to and in some cases surpassing the human expert performance.
So for deep learning, we applied we applied deep learning to our model to enhance the performance and results. The first hidden layer has 12 hidden layers and activation function ReLU. The second has 18 nodes and activation function ReLU. The output layer has one node with activation function sigmoid, and we define the optimizer as the efficient stochastic gradient descent algorithm ADAM. And this is a popular version of gradient descent because it automatically tunes itself and gives good results in a wide range of problems and use epoch size of 10 and 20. Our results improve with each epoch with an accuracy of 0.8865 and loss of 0.2801. Um, and these are the works cited. Thank you.
Thank you all.
So the time